So we'll start the class. So good morning, everyone. Welcome to the class on syllogism. So the concept on syllogism or Venn diagram is one of the concepts which is very common in reasoning section. And when whichever exam we talk about, either it is related to a placements or either related to any government, always you definitely find a problems related to syllogism. So I will solve the problems on syllogism by using Venn diagram, and there are a lot of other methods also there. You can see different people teaching this topic differently. So I'll share my opinion of how I solve these problems. You are most welcome to use your own opinions or your method to solve the question. Ultimately, it is reasoning, and here what matters is like how fast you can solve the question. So the concept what we normally use here, concept is like all A are B. So this then some A are B, then some A are B, some A are B, then some A are not B, some A are not B, and then no A are B, no A is B or no A are B. So all the questions will be done based on this concept. Okay, so if I'm talking about all A or B, if I'm using the term called all A or B, what do you mean by all A or B? So all A or B means this is the diagram what I'm talking about. Then if I say that some A or B, if I'm saying some A or B, what would be the diagram? The diagram can be like this. Some A or B, your diagram can be like this. Some A or B, or your diagram can be like this. So you can understand this. So some A or B. So if you see this diagram, if you simply focus on this diagram, if you simply focus on this diagram, so what this diagram is telling, all A or B, or it is also telling that some B or B. So some B are A. What are those B which are A? That is this. So you can understand this. Then if I'm the third pattern, some A are not B, some A are not B. So when I'm saying some A are not B, it means definitely. When I'm saying some A are not B, definitely it means what? It means that definitely all A are not B. Definitely all A are not B. So you can understand that. So some A are not B. So some A are not B. So your diagram can be either like this. Okay, your diagram can be either like this. Okay, or your diagram, you can think of the diagram like this. So you can think your diagram like this, where talking about the relation between A and B. So all the A cannot be the part of B. There would be little bit A left, which cannot be B. That's why some A are not B. So you can understand. So whenever doing the problem, some A are not B. So that is little bit confusing. So whenever we have to do a problem where statement is given like this, some A are not B. So we always test whenever you are solving a problem, whenever we have to test, whenever remember this, whenever we have to test some A are not B, whenever we have to test some A are not B, then how will you test this? Then apply logic. What logic you need to use? Logic is that test this, test all A or B. So test all A or B. So if the answer is, if you get correct or true, if you get the answer true means all A or B, if you can prove that, then some A are not B, then some A are definitely not B. Okay. But if you are getting an answer called false, you are getting an answer called false, it means what? Then it means some A are not B. Some A are not B. Doing this experiment directly is little bit difficult to do whenever we are solving the question. To come up with a conclusion with some A or not B, it is difficult to do. So that's why in exam, whenever we get a problem where if the statement is written called some A or not B, so we don't test some A or not B because that is difficult to tell. Instead of that, we test all A or B. So if you are getting all A or B is true, means definitely the sum A or not B. And if you are getting all A or B as false, then it means some A or not B. So keep that in your mind while solving the problem. Then the next part, the last part was just the last part in the statement can be no A or B. No A or B. So that is very simple. No A or B means there is no intersection between A and B. They are mutually exclusive event. If I talk in the language of probability, we say that such kind of events as a disjoint event or mutually exclusive event. For such events, if I talk in the term of set theory, for such event, the intersection of A and B, that would be null set. So there is no intersection between them. Anyway, we're not going to discuss the mathematical concept here. So now to make you understand some A and not B, I believe many of you are still not very much clear with this. So I'll take an example for that. So I'll do this problem to make you understand this concept. So suppose here there's a, I believe you can see this font size. So suppose it is like this. Uh, Here the line is like all pen are cheered. You can see the statement. So here, first let me make you understand what is given. So few statements, whenever you're solving the problems on syllogism, you will be given few statements. Okay, so you have to consider those statements to be true. So although it looks that those statements are illogical in the context of general knowledge or basic sense approach, but even then, whatever is written statement, you have to believe that to be true. And based upon whatever is written in the statement, you have to come up with a conclusion. Okay, your conclusion should be based only on what is given in the statement. There, you don't have to use your knowledge of science or knowledge of maths or any other concepts to put into there. So you need to just think that your world is limited to the idea what is given in the statement. Okay, and based on that, you need to solve the problem. Okay, so if you see this, let's suppose a statement one, all pen are chair. So all pen are chair, all pen are chair. That is given. Statement one, all chairs are pot. All chairs are pot. So all chairs are pot. So if I talk about pot, there's no relation given about pot and chairs. So pot can be either here. All all chairs are pot. So all chairs are pot. So all pen are chair. Okay, and all chairs are pot. So all chairs are pot. All chair are pot. Yes, I hope you're understanding. Then next thing is some chair are not drawer. Some chairs are not drawer means some chairs are not drawer means all chairs are drawer. That is not true. All chairs are drawer. That is not true. Your chair can be like this, or your chair can be like this. I hope you are understanding. Anything can be a chair. So sorry, what this drawer? Sorry, not chair, drawer. Your drawer can be like this. Your drawer can be like this, or your drawer can be like this. Okay, so anything can be a drawer. I hope you are getting the logic. So drawer can be, your diagram can be like this, or your diagram of drawer can be like this. Only thing we know that some chair are not drawer. Only thing we know that some chairs are not drawer means all chair, all chair are drawer. It is not true. All chair are not drawer. We are sure that is not true. And then no pen is paper. Then no pen is paper. So if I'm saying no pen is paper, it can be no pen is paper. Diagram can be of this, can be like this of pen and paper. Or pen and paper. It can be like this of paper. The diagram can be like this, or your diagram can be like this. So there's no relation is given about paper and drawer, paper and pot, paper and chair. We only know about pen and paper. So the diagram can be anywhere. You understand? So all the conditions should be there in your mind. Okay, and here you will go with only that conclusion which should be 100% true. If there's any iota of doubt exists, okay, or in out of all possibilities, if you see that in any possibility that conclusion is not tending to be correct, then you will not believe that conclusion to be correct. You only accept that conclusion which should be correct in all the context. Okay, now first conclusion written, then some drawer are not pot. Okay, so the now first conclusion is some drawer are not pot. So whenever you get conclusion like this where there's some not is given, then the best way to do this problem, the best way to do this problem, test what? Test this, that test what? Test all, what you do, test here, what you do, test that all, test all here, what you do, test all drawer are pot. Test this, all drawer are pot. You test this. If you have to do this test that some drawer are not pot. So for this, what you do, you test this all drawers are pot. So if you're getting all drawers are pot as true, then means some drawer are not pot will be false. Okay, or vice versa. So you have to do like this way. So here let me just reframe this diagram again. So let me just reframe the diagram again. So here it is written all pen are chair. So if I just draw that all pen are chair, all pen are chair. Okay, all pen are chair. Okay, then some all chairs are pot. So what I need all draws are pot. So all chairs are pot. Then all chairs are pot. Okay. Then some chairs are not drawn. So some chair are not drawn. So you diagram. So some chair are not. So I can draw this. Suppose draw this. So this. So what I'm trying to test, I'm trying this. All draws are pot. This I'm trying. Is this true or not? All draws are pot. I'm trying to test this. Then last thing, or some chairs are not drawn. Some chair not okay. Then no pen is paper. No pen. You have pen and paper. No pen is paper. No pen is paper. Now, what I need to, the conclusion is written here. Some drawer are not pot. So whenever you have to prove or disprove some not, then you can't do some not like that directly. You have to do it indirectly. So if I have to prove or disprove this, some drawers are not pot. So I will test, I will test all drawers are pot. Is this a true or not? So all drawers are pot. So for that I found the diagram. So in this diagram, all drawer I'm getting inside pot. Okay, now I need to see that is this diagram what I've drawn, is this diagram is violating any of the statement. If this diagram is not violating any of the statement, it means all drawers are pot. If all drawers are pot, then definitely some drawers are not pot. So if I hope you're understanding. So I need to test this, or if this diagram what I've drawn according to my diagram, all drawer are pot. That diagram I have trying to fit as per what is given in the statement. If I'm getting all drawers are pot to be true, then some drawer are not pot is false. While if I get this false, then some drawer are not pot would be true. So now this is a diagram what I've drawn. Let me just read the statement again. All pen are chair. Yes, all pen are chair. Yes, no problem. Then all chair are pot. All chairs are pot. Yes, all chairs are pot. Fine. Correct. Then some chairs are not drawer. Some chair are not drawer. Correct. Yeah. Few part is left. Then some chairs are not drawer. You can see this, this, these chairs are not. These chairs are not drawer. So then no pen is paper. Yes. So anywhere did you find that the diagram what I have drawn is violating any of the statement? Everything is correct. Okay, and through this diagram, what I'm trying to show, I'm trying to show that there's a possibility, there is 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 a possibility that there is a possibility that all draws are pot. Okay, so if there's a if all drawer is pot, if this is true, if this is true, if this is true, then some drawer, then some drawer are not pot. That is false. It means the statement that some drawers are not pot. This is not. Okay. Then next thing is that all pen being drawer is a possibility. All pen being drawer is a possibility. You can see that in this diagram only you can see you can see that all pen being drawer. You can see, yeah, in this diagram only all pen being drawer. Drawer is in blue color and pen you can see it is in pink color. So you can see there's a possibility that all pen can be drawer, or it can be that all pen cannot be drawn. That can also happen. So I'm talking possibility. Possibility means that out of n scenarios what are possible, is this scenario is there or not. So that is possibility. That is not 100%. I hope you understand. We have studied probability, so that we know that possibility. So like here we are working on scenario building. So out of n scenarios what you are building, so is this a possibility? Yes. So means what is your answer? Answer is only conclusion to true. So these kind of question when you solve, right? So like this questions will be, this would be the date question will be given to you. This will be the question given to you. They will tell you which option, like option A, B, C, D, E, when you choose option A or when you choose option B or C or D or E. In the exam, if you have 5 options per question, then maybe this would be the kind of 5 options. Or if there are 4 options, then they'll change the options accordingly. So read the option very clearly. Option A means what, option B means what, option C means what, options D means what, and accordingly you can choose your option. So this kind of syllogism or deductive reasoning or data sufficiency, there you need to make sure what is option 1 means, what is option 2 means, A, B, C, D, what that means. You can read them and you can understand. So now see one more problem like that. So here, so now you can see this question number 9, like all fan are chair. So you can see this. Just copy this question. So we now try to draw the diagram. So all here, all fan are chair, all fan are chair, all fan are chair, all fan are chair, okay. Some chair are pot, some chair are pot, some chair are pot. Diagram can be like this. Some chair are pot, so all fan are chair, and some chair are pot, some chair are pot. It can be like this. Some chair are pot, or your diagram can be like this. Anything. I hope you understand it. Your diagram can be like this. We focus on that diagram, which is minimum overlapping diagram. So some chairs are pot, then some chairs are drawer, then some chairs are drawer, then some chairs are drawer. You can see, then some chairs are drawer, some chair are drawer. Then no pot is drawer. Pot is drawer. Then some chair are drawer. You can see some chair are drawer. No pot is drawer. You can see no pot. Diagram can be any way, so you can understand. But so anyhow, you can set the diagram. So you need to always put all the possibilities in your mind while drawing the diagram. Okay. So then this is what given. Then what I need to do, I need to test my conclusions. So the first conclusion is some fan are not pot. So first I need to test this. Some fan are not pot. Some fans are not pot. So if I have to test some fan are not pot, I'll test all fan are pots. This true. It can be. Is this can be true or not? Is all fan are pot. Let's test this. Is this possible or not? So some fan are pot. So you know that all fan are chair. Okay, you know that some chair are all fan are chair. All fan are chair. Okay, all fan are chair. All fan chair. All fan chairs. Okay. Then some chair are pot. Then some chair are pot. Some chair are pot. Can I draw the diagram like this? Yes. Sir, why you are drawing the diagram like this? Because you knew that, right? I need to test this. Test this all fan are pot. That's why I'm trying to test that that my diagram should not violate any. So then some chair are pot, correct? That then some chairs are drawer. Then some chair are drawer. Then some chair are drawer. Some chair are drawer. Okay, and no pot is drawer. That by anyhow did I violate any of the statement? You can see all fan are chair. Okay, all fan are chair. Yes. Then some chair are pot. Yes. Then some chairs are drawer. Some chairs are drawer. Yes. Then no pot is drawn. Yes. So by anyhow did I violate any of the statement? No. But but somehow I prove I get that possibility that all fan are pot. So if I'm getting that possibility that all fan are pot, it means then some fan are not pot. That is pot. I hope you understood this. Now, then the next, the next. Then the last one is some chairs are not pot. Some chairs are not pot means I test this. All chairs are pot. Test this. All chairs are pot. some chairs are not pot means I'll test this all chairs are pot. How will I do? This is fan. So all fan are chair. All fan are chair. Then some chairs are pot. So all chairs are pot. So some chairs are pot. Then some chairs are. Here I would test this. All chairs are pot. Some chairs are pot. You can understand that is not true. Some chairs are pot means pot can be inside this, but all chairs are pot that then I'm violating that. I hope you're understanding. Then you can understand all or some chairs are pot means some chairs are pot means one of the possibilities can be all pot are chair, all pot are chair, but all chairs are pot, that is not true. Okay. Here I have to prove that all pot are chair. So that is not true. But even then, I just show you, like I'll just show you that also. So just to prove or disprove, if you want, you can do that also. But then that way it will not work. Just for your first time because we are doing so, let's do that also. So all chair are pot. Okay, so some chairs, if all chair are pot, if all chairs are pot, you can understand that if all chairs are pot, you can understand if all chairs are pot, then some chairs are pot. Definitely that would be true. Definitely that would be true. I hope you are understanding. Definitely that would be true. So I'm just wondering one of the possibilities. Suppose that is the possibility. Just ignore that. Okay, so some chair are pot. Okay, so here I'm getting this. All chairs are pot. You can see that. Here I'm trying to prove that is this true or not. Is this true? What I'm trying to do. Is this true or not? That I'm trying to find the answer for this problem. Is this true or not? So I'm trying to find is this true or not. Uh, so so here all chairs are pot, some chairs are not pot. So is this true or not? So some chairs are pot. You can see that some chairs are drawer. You can see some chairs are drawer. Now see this. Now you see my diagram and see some you can see that some chairs are drawer and no pot is a drawer. Now if I draw drawer, if I draw drawer, then drawer should touch chair. If I draw drawer, then drawer should touch chair. And if the drawer will touch chair, then pot and drawer, they like no pot should be drawer. You understand? No pot are drawer. You know that no pot are drawer. You know that no pot are drawer. Okay, and you know that some chair are pot, and you know that some chair are you know that some chair are drawer. No, you know that some chair are drawer, and according to my diagram, if you see my diagram, if you see my if you see my diagram, if I try to touch chair and drawer, if I try to touch chair and drawer, then somehow the pot and drawer will come in contact with each other, but no pot is drawer. That is given in our statement. No pot is drawer. Okay, so in that way you can understand. In that way, I hope you are understanding. That way you can understand that all share are what, that is false. So if that is false, then some share are not what, that is true. So here this will not be true. This will be clear, everyone. So now you see this. Now you see this. These are statement. These are statement one. S1 means statement one. S2 means statement two. And based on these statement one and two, you have two or three conclusions. So S means here statement. C here means conclusion. And C here means conclusion. Here C means here conclusion. Okay. Now, whatever is given in the statement, you consider to be true. Either they are true or not true. So you consider them to be true. Okay. And based upon that, whatever is given statement, you consider that to be true. And based upon that, you work on conclusion. Okay, guys. And you will choose option A if conclusion one is true. Okay. Conclusion B is false. You choose option B if conclusion one is false, conclusion two is true. You choose option C if either of the conclusion, either A or two is true. Okay, and you go with option D if neither of them will be true, or you go with option E if both of them are true. Okay, guys. So based on this, we'll solve the question. Okay, so based on this, we can solve this question. So you can see this. So here, if you see the statement one, all cat are rat. Statement one, you can see the all cat are rat. You can see the statement one, all cat are rat. Okay. Then all rat are pets. All rats are pets. That is statement two. Okay. Then conclusion one. Conclusion one is some cat are pet. Conclusion one. Okay, so this is the statement. Two statements are given. So all cat are rat. Okay, I've drawn the diagram. All cat are. Statement two is all rat are pets. All rat are pet. Yes. Then what is conclusion one? So then I need to see that two conclusions are given. Like is that both are correct or any one is correct? What all I need to see, and based on that I will choose option A, B, C, D. So conclusion one, some cat are fat. Some cat are fat. You know that. See, understand, guys. If all cat are fat, if all cat are fat, then here you can know that, no? Because all cat are rat and all rat are fat. Definitely all cat will be fat. So then some cat are fat. So that would be true. I hope you are understanding, right? So if all A are B and if all B are C, then definitely all A are C. If all A are C, then definitely some A are C. So guys, I hope you are understanding. You all are understanding this part. That if all A are B, if all B are C, then it means what? Then it means all. It means all. If all A are B, then if all B are C, then it means all. It means all A are C. It means all A are C. If it means all A are C, if it mean all A are C, if it mean all A are C, then some A are C is definitely true. Definitely true. Then this conclusion is definitely true. Conclusion two is all pets are cat. All pets are cat. So all pets are not cat. Why? Because all cat are pet, but if you see this pet, this pet, this pet, this pet, they are not cat. You can understand this much pet are cat. This much pet which I've done with green color. This much pet are cat, but those pet which are outside the boundary of cat, they are not cat. So all pet are not cat. Okay, some pet are cat. You can understand. Some all cat are pet. Okay, and some pet are cat. Some pet are cat. I hope everyone is understanding. Anyone, any doubt, any question? So do this question number 2. So like this, you can solve other questions. Like question number 2, some pen or paper. So some paper or pen, sorry. Some pen or paper and some paper or pen, they are two different things. So some paper or pen. So some paper or pen. So some paper or pen or diagram can be like this. Paper or pen is different from some pen or paper. So paper or pen and all the pencils are pen. All the some paper are pen. All the pencils are pen. All the pencil pen. All the pencils. All the pencils are pen. All the pencils. Suppose this is pencil. All the pencils are pen. Pencil can be here or pencil can be here. I don't know. So all the pencil are pen. All the pencil are pen. Now, so these are the two statements. Based on that, you can see the conclusion. Conclusion is some paper are pencil, some paper are pencil. So you can see that some paper are pencil. So you can, if you think about this diagram, if you think about this diagram, this is pen. These are the statement. Now, if you think of this diagram, pen, paper, this is pencil. Think about this diagram. So here, are you getting this some paper or pencil? No, you are not getting, right. I hope you are understanding. We'll go with that conclusion, which should be 100% true. Okay, so three possibilities are happening here. So out of three possibilities, in two possibilities, okay, in two possibilities, some paper or pencil, but in one possibility, uh, no paper or pencil. I hope you're understanding. Then you go with that possibility, which should be 100% true. Okay, then some paper, some pen or pencil, some pen or pencil. So that will go in every case, some pen or pencil. I hope you understand. Some pen or pencil that will go in every case. You can see that because all pencil are pen, so definitely some pen would be pencils. That would be true in all the cases. I hope you understand. Then see this. Some ant are pants. 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 Okay. All pants are tent. All pants are tent. All pants are tent. So you can see that all pants are tent. Tent can be either, this can be either tent or tent can be pant are tent. Okay. Then some pant are, okay. These are two conclusions. Some ant are pant and all pant are tent. Okay. So now based on this, third conclusion one is some pant are ant, some pant are ant. That would be true only. Some A are B, some A are B. And if I'm saying some B are A, so definitely. So although they are two different statements, but if some A are B, then definitely some B would be A only. So some pant are ant, and if it given some pant are ant, definitely that will be true. You can see in all the cases that would be true, that some pant are ant. You can see some pant are ant. Here you are getting all pant are ant. So if all pant are ant you are getting, so means some pant would definitely would be ant. Okay, no tent or pant, no tent or no. Here it is given all pant are tent. Okay, so if all pent are tent, definitely then some tent would be pen. Okay, here they're telling no tent are pet. That is not true. Very simple. Then statement one you can read here. Statement one is all mats are rats. All mats are rat. All mats are rat. No rat is fat. No rat is fat. Conclusion one. Some mats are fats. Some mats are fat. Not at all true. You can know that it cannot be true because no rat is fat and all mat are rat. So some mat anyway they are touching fat. That is not at all true. Okay. So no fat is mat. No fat is mat. That is true. That is true. That is clearly visible. Now you can see question number 5. Some casuals are formals. Some casual are formal. Some casual are formal. Some casual are then all formals are expensive. Then all formals are expensive. All formals are expensive. Can be diagram can be like this. The diagram can be all formals are expensive. All formals are then the third statement, all expensives are elegant and all expensives all expensives are elegant. Then these are the three statements. Okay, based on that we read the conclusion. First conclusion, all formals are elegant. All formals are elegant. Correct on this. All formals are expensive and all expensives are elegant. So definitely all formals will be elegant. Some casuals are expensive. Some casuals are expensive. Some casuals are expensive. Some casuals are expensive. Some casuals, some casuals are expensive. Here, all casuals are expensive. You get it? All casuals are expensive. Second one should also be true. Conclusion two should also be true. Both should be true. One, some, but anyway, like here I'm getting confused. Right? So some casuals are expensive. So you can test this that some A R B. You want to test this. So test it with this. No ARB. No ARB. That is true. Then some ARB. Some ARB. That just testing that I need to be 100% sure. So some casuals are formal. So there's an intersection between casual and formal, right? Yeah, some casuals are formal. Some casual are formal. And all formal are expensive. Some casual are formal. So some casual are formal. Okay. All formal are expensive and all formals are expensive. All formals are expensive. All formals are expensive. And then all expensive are elegant. And then all expensive are elegant. So here casuals and elegants are touching each other. Casuals and elegants are some casuals are expensive. Some casuals and expensive are touching each other. You cannot because all formals are expensive. So do not think about the possibility. So suppose this is casual, this is formal. All formal are expensive. So if all formal are expensive, you can say that here because all casuals are expensive. If all casuals are expensive, then definitely some casual would be expensive here. Some casuals are expensive, some part of casual and some part expensive. Definitely they will touch. So the answer for this would be both they are true. So this is also true, this is also true. So the answer for this would be this. Both conclusion 1 and B follow option. Conclusion 1 and B follow. The answer for this would be option A. Conclusion here. This should be option B. Both conclusion 1 and B follow. Now you can see this statement 1. You can see the statement 1. All roses are red. All roses are red. All roses are red. All roses are red. Some red are color. Some red are color. Some are color. All roses are red. All roses are red. Some red are color. Some red are color. So color can be this. Can be this. Can be this. I don't know. So some red are color. Okay. Then all colors are paint. Then all color are paint. Then all color are paint. You can understand this. All color are paint. So some roses are red. All roses are red. Then some red are color. Some red are color. Okay, and all color are paint. So this is the statement given. First conclusion: some red are paint. Some red are paint. So yeah, so they will always be intersection because some color are red, some color are red, okay. Some color are okay, some red are color or some color are red. So the diagram will be like that. So some red are color. Okay, so definitely there's intersection between red and color, and then all color are paint. So all color are paint. The paint can be like this, or paint can be like this. So in every case, you can see here all paint are red. Here some paint are red. So some red are paint. So definitely some red would be paint. So either all paint are red or some paint are red or all red are paint. In every possibility, some red are paint. In all possibilities, some red are paint. Okay, and then all red are rose. All red are rose. All red are not rose. Some red are roses, but all red are not roses. You can see this red is not rose. This red is not rose. You can understand this is not. You can see all towns. You can see all question number 7. You can see all towns are city. You can see all towns are city. You can see all towns are cities. All towns are cities. All cities are urban. All cities are urban. All cities are urban. Okay. Then some urban are rural. Then some are diagram can be diagram. Some urban are rural. So some urban are rural. Then conclusion one is the conclusion one is some town are rural. That is not true. ruler are town. All ruler are town. All ruler are town. Neither one will do, neither two will do. Answer the option D. Option D. Neither one or neither two will. So now, this. Now you can see some phone are, so your statements are some phones are table, some phones are table, some phone are table, some phone are table, table, some phone are table, all table are sofa, all table are all table are sofa, all table are sofa, some phone are table, some phone are table, all table are sofa, all table are sofa, all table are sofa, all table are sofa. So you can see some phone are table, all table are sofa. Okay, no phone is designed, no phone is designed. Some no phone is designed, and some sofa are not designed. Some sofa are not designed. Some sofa are not designed. Means all sofa is designed, not sofa is designed is definitely not true. Understand this. Some sofa are not designed. So in any case, some means all sofa are not designed. So in any case, all sofa are not designed. That is, all sofa being designed is not a possibility. That is 100% true. You can see that. So if some sofa are not designed, means all sofa are designed is not at all true. There is no possibility of that, because if all sofa will become designed, then some sofa are not designed can't be true. Here it is given statement that some sofa are not designed. That means that all sofa are designed. All sofa are designed. Definitely that is not true. All sofa are designed. All sofa, when you see sofa and design, there will be some part of sofa which cannot be designed. Okay, there will be a part of sofa which cannot be designed. It's written a new phone is designed. Phone and design, there is no intersection. Design, there is no intersection. So you can see that. So all table, some phone are table. Okay, all table are sofa. All table are sofa. Then some sofa are not designed. When we talk about sofa, so when we talk about sofa and design, so this diagram is not possible. Sofa and design, then this diagram is not possible. We do love that diagram. So this is the only possible diagram. So here, what is the first conclusion? First conclusion is some design are not able. If I have to prove or disprove this, some designs are not able. So the first thing what you do to disprove all design are able. Just try this. All design are able. If this is true or not. If this is true, then definitely some design are not able. if this is false, then some design are not able to do. All design are able. See that is this possible or not. Some phone, some phone are table, some are table. Okay, all table are sofa, all table are sofa. Okay. All design are table and all design are table. So then no phone is designed, no phone design. So no phone is designed. This much area phone can nowhere the design can come. No phone is designed. No phone is designed. Then some sofa are not designed. Some sofa are not designed. All design or design are table. Inside the table, design will come. There, there, you're getting all sofa being designed. Here, all sofa, here you can see this is design. If this is design, then all sofa, so come again, some sofa are not designed, some sofa are not designed. You can see all these are sofa which are not designed, some design. So you can see these all are sofas which are not designed, correct? So some sofa are not designed. So all these are sofas which are crossed. So all these are sofas which are crossed. They're not designed. Yeah. So some sofas are not designed. So you can understand this. Some sofa are not designed, but here all designs are getting inside table and design and phone. All you know that no phone is designed. You're getting that possibility, correct, right? So if this is true, then this is false. I hope I'm making sense to you. So then it is written that some sofa are not designed. So if it is given statement that some sofa are not designed, then all the sofa being designed is not a possibility. That's 100%. You don't have to do that. Because it is given already that some sofa are not designed. Means 100% all the sofa cannot be designed. So if 100% all the sofa cannot be designed, so that means all design can be sofa. I hope you understand. That means also all design can be sofa. All design can be sofa, but all sofa cannot be designed. Because if all sofa become designed, then some sofa not designed cannot be. Now you can read the next part. Statement is given to you that that some purple are yellow, then some purple are yellow. Some purple are yellow. That is statement is given to you. Some purple are yellow. So some purple are yellow. Some purple are yellow. That is statement given to you. Some purple are yellow. Some purple are yellow. And then no purple is red. And then no purple is red. Then the next statement given to you is no purple is red. No purple is red. Then no purple is red. Then it is given to you that no purple is red. You can see that no purple all red are blue. All red are blue. All red are blue. All red are all red are blue. You can see that all red are blue. Then all blue are green. Then all blue are green. Then read this. You can find this much is given to you. Conclusion. Conclusion is like some green are not purple. So you have to do this. Some green are not purple. Means what I have to prove or disprove that all green are purple. All green are purple. I need to prove or disprove this. All green are purple. So you can see that again I have to draw the diagram. So again I have to draw the diagram. Some purple are yellow. Some purple are yellow. All green are so no purple is red. No purple is red. All red are blue. All blue are green. All green are purple. So how this goes? So all green. So no purple is red. No purple is red. No purple is red. Okay. All red are blue. All red are blue. Suppose all red are blue. All blue are green. Then all green are purple. So all green are purple. All red are blue. All red, all red are blue. All red are purple. This is are some purple are yellow. Some purple are yellow. If you have green inside that, all green are purple. All green are purple. Inside green you have so but purple and red cannot be together, right? Purple and red. No purple is red. So because all red are all red are blue and all blue are green. So means what? All red are green. So means definitely the red should be inside green. Definitely the red should be inside green. Definitely the red should be if red is inside green and here if green is inside purple, if green is inside purple, we know that all red are green. So all red are green. And here I need to prove or dispute that all green are purple means all red are purple. And here it is written that red and purple cannot be together. So red and purple cannot be together. What that means? If red and purple cannot be together, this is false. If this is false, then some green are not purple. Some green are not purple. That would be the first conclusion should be the first conclusion should be I hope you understand. Second conclusion, some yellow are not blue. Some yellow are not blue. Second conclusion is some yellow are not blue. So test this all yellow are blue. So which is this all yellow are blue. So to test this all yellow are blue. So is this true or not? So for that again I'll draw the diagram. So all yellow are blue. This is purple, then yellow, all yellow are blue. Yeah, it can be blue. This is purple, this is yellow, and then no purple is red, no purple is red, and all red are blue. All red are blue. Yeah, all red are blue. So it means all yellow are blue. If all yellow are blue is true, then some yellow are not blue is false. The answer for that would be very option B. You can see this. You can see the statement that no computer is catching, no computer, no computer is catching, no computer is catching, and then no computer is catching, then some catchy are cooking, then some catchy, all cookies are fine, all computers are system, all computers that is what given to us. You can draw a lot of diagram based on this possibility. What I need to do first, supposing some files are not system, if I just have to test all system, I have to test this possibility. Files are system, I have to test the possibility. Test this possibility. All files are system. So computer, no computer is catchy. No computer is catchy. No computer is catchy. So some catchy are cookies. And some catchy are cookies. All cookies are fine. All fine are system. All computers are system. All computers are system. Like this. Here, then, yeah. So this would be true. Then all, all some catches are cookies. Some catches are cookies. Then, all cookies are fine. All cookies are fine. All cookies are fine. So you're getting all files as system. So that is true. So that is true. No problem. You're not violating the data. This is not. Then so all computer being cookie is a possibility. All computer being is a possibility. First, let's see that let's draw the diagram. Let's see if it does not violate any condition. It should not violate any condition in the statement what is given to us. So all computer, just need to see that possibility. All computer, no computer is catchy. Catchy, no computer is catchy. Some catchy are cookies. Some catchy are cookies. Some catchy are cookies. This can be the diagram. So here all computer you're getting all some catchy are cookies. Yeah, correct. Some catchy are cookies. Then all cookies are fine. Then all cookies are fine. Then all cookies are fine. All computer is a system. All computer just seeing that this is a possibility. All computer are cookie. So all computer cookie that possibility is that is possibility there. The answer will be option B. So you can see this. So, see this statement. Some bikes are car. So some bikes are car. Some bikes are car. All then all ships are train. So at least some buses are car. At least some buses are car, or some buses are car. Both mean same thing only. So some buses are car. Some buses are car. Some buses are car, and no bus are ship. No bus are ship, and all ships are train. No bus are ship. No bus are ship, and all ships are train. Minimum overlap diagram I draw. So some bike are car, some car are bus, or some bus are car, same thing. Then all ships are train, then no buses are ship, and all ships are train. Okay. So then conclusion one, that all cars are train. All cars are train. All cars are train. So you are not getting that. Okay. All cars are train. So minimum overlap diagram from there, that is not getting. Some trains are ship. Some train are ship. Some train are ship. Yeah. So all ships are train, but some train are ship, because all ships are train. It is given. Definitely some. Definitely some train are ship. Okay, some buses are bike. Some buses are bike. No, you can see in minimum overlap diagram. Then some car are buses. Then some car are buses, because it is given that some buses are car and some car are buses. Both would be correct. So here 2 and 4. So for this would be if only 2 and 4. So question number 2. Try to read that. Then you can see question number 2. Some cake are rose. Some cake are rose. Some cake are rose. All roses are truck. All roses are truck. All roses are truck. No truck are brick. No truck are brick. Then some bricks are at least some brick are hotel, or some bricks are hotel. Some bricks are hotels. Some bricks are hotel. So then some truck are cake. Some truck are cake. So you can see that. So all some cake are rose and all rose are truck. Some cake are rose. Some cake are rose. Some cake are rose, and all rose are truck. And all rose are truck. All rose are truck. So truck would be either here or the truck would be either here. So if I say that some truck are cake, so some truck are cake. So here you are getting some truck are cake. Here you are getting some truck are cake. Some cake are truck. I think all possibility you are getting that diagram, that some truck are cake. So lot of cake. Then some brick are rose, but some brick are rose. So you're not getting one lab. All cakes are truck. All cakes are truck. Here you can see this and this if you're comparing. You're getting all cake are truck, but if you compare this and this, all cakes are not truck. Some cakes are truck, or some truck can be cake, but all cake cannot be truck. Some hotels are cake, some hotels are cake. Only one follows. You can see all tigers are dog. 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 Then some tiger are cat. Then some tiger are cat. Then some tiger are cat. All cats are lion. Cat are lion. All cows are lion. All dog, then tiger, then cat, then lion, then cow. Some dogs are lions, some dogs are lions. So here some dogs are lions. So this is dog, dog. This is tiger. All tiger are cat. All tiger are dog, sorry. And all some tiger are cat. Some tiger are cat. Some tiger are cat. If cat is inside, then all cat are lion. So definitely they would touch intersection between dog and lion. Some dogs are dogs. So if I see, some tiger are cat. Some tiger okay. And all cat are lion. Cat are lion. Cat are lion. Some dog are lion. So, and some dog you are getting all dog are lion. Here you are getting some dog are lion. Yeah, all case this is true. Then some cows are dogs. Some then all tigers are dogs. All tigers are dogs. Some tiger are cat. Then all cat are lion. Then some, cow is cow. Some cat are lion. Some tiger are cat. Then all cows are lion. All cows are lion. Here is a cow. All cows are lion. This is dog. This is dog. Right? Yeah. So here all cows. This dog and cow. Some cows are dog. So it can be true. It cannot be true. Some lion are tiger. Some lion are tiger. Some lion are tiger. Yeah. Some lion tiger. Always there is intersection between lion and tiger because they always be intersection between when you see lion and tiger, they always be intersection between them because when you talk about some lion are because some all cat are lion, all cat are lion, all cat all cat are lion, and some cat are tiger. So there's always an intersection between lion and tiger. So you cannot remove them. Yeah. So all cats are dog. All cats are dog. All cats are see from this diagram, all cats were not getting down. Cat can be outside also. 1 and 3 follows here. Like this, you can think about the possibilities, then all the possibilities which are possible. You can think about like this. If you want